Okay.
Sir,
So suppose
yes, sir. A few of our participants have some query. So
they have some queries.
yes,
Yes. Okay. Oh, yes. So have they written in the chat box or what? No. Okay. They may ask me directly.
yes,
Yes.
yes, Shashank, Shekhar.
Good morning, sir.
Good morning.
Sir, I want to ask that you showed that the pi number has four decimal places after the 3 point, and if we have to show more digits like 10 or 16 digits, how could we show it here?
Yeah. Yeah. So in that case, you have to declare that variable as a double. I mean, this is what maximum it can do. When
Yes.
you have a variable, either a single precision or a double precision, then MATLAB tackles it differently. The memory space it keeps for single precision is different from the memory it keeps for double precision. But on the display monitor, it will show only 4 digits after decimal.
So if it is we have already declared it as a double precision, and it still will show 4 digits
Only four
only.
digits after decimal.
Yes.
Yes, yes, yes. Because that
Okay.
is the, you can say, the limitation of our display. Our display is basically an 8-bit display. Let me tell you, whatever is being displayed on your monitor, है ना, that is as an 8-bit. All the monitors in this world are 8-bit monitors. Remember it. Okay?
Yes.
Their memory is very much limited. That's the reason. Not otherwise. It's not a limitation of MATLAB. It's a limitation of the display. Right?
Yes, sir.
Yeah. Any
Thank you,
other
sir.
question? Uh,
If any
so shall
participants
we
have any
continue?
questions,
Yeah. Any question? Yes, please, please.
yeah, if anyone have any questions, they can ask directly. Please unmute. If you have any questions from previous session, you can ask. Please do not hesitate. So
I guess
So
if there is no
Ms.
question,
Divyanshi,
yeah.
do you have any query? You have raised your hand. Ms. Divyanshi?
Sir, but in other programming languages like Python, they don't have that limit, that 8-bit limit that is there for the 4 decimal ones. They can display up to
for that is the yes, yes, yes. But no language doesn't have a limitation. Language doesn't have. MATLAB process it nicely, but on the display it will show only this. Okay, that's the reason.
okay.
Inside the memory, the number is well represented. If the mantissa, if it has result, in fact, in let me tell you, in double precision, it keeps 11 bits for the exponent and 52 bits for the mantissa and 1 bit for the sign bit. So therefore, a total of 64 bits in the memory are for the for representation of the number. And if suppose 60, as I told you, 64 bits in the memory are reserved. So therefore, it can represent. I'll write here. It will represent 64 bits. It keeps reserved for a double precision number. For a single precision number, it keeps 32 bits in the memory for single precision number. Okay. So if there are for this 64 bits, I am telling you, for 64 bits representation, one is the sign bit. This is sign bit. 11 bits are for the exponent and 52 bits are for the mantissa. Sign bit, exponent, mantissa. Total 64. So therefore, the maximum number, positive number, that can be represented in 64 bits that is 2.22 into 10 raised to the power plus 308. Well, sorry, this is 1.79 into 10 raised to the power plus 308. This is the maximum positive number. You can see such a large number is there. Okay. So this number can be represented by MATLAB in the computer. The minimum number is minimum positive number. Minimum positive number, I am telling you. 2.22 into 10 raised to the power minus 308. This is the minimum positive number. And similarly, maximum negative number is minus 1.79 into 10 to the power 308. And minimum negative number is minus 2.22 into 10 raised to the power minus 308. So I think you can well appreciate. I just told you numbers, don't remember them or something. Just for the purpose that such large numbers are represented by MATLAB in the computer. Now, when MATLAB displays it on the screen, then it will display very large number. It will display in this format, 10 raised to the power something format. That means the floating point number. In this floating point number, this part, the mantissa part, this is the mantissa part. The mantissa part, it will not show more than 4 digits after decimal. This is what I'm saying. It will show 10 raised to the power minus whatever it is. Okay. But don't think that, the numbers which are, if suppose more decimal parts, decimal digits are shown, then it will become more precise. No, it's not. Precision is achieved by this exponent part, in fact. How large a number is or how small a number is. So there is no limitation up to this for MATLAB. So large number, 1.79 into 10 to the power 308. Such a large number is represented in memory. But on the display, it will show only 4 digits after decimal for this mantissa part. Okay, this is what I'm saying.
So while calculation, like suppose you're calculating area of a circle, so pi r square. So will it use that large
it will show up to 4 decimal digits only. Only 4 decimal digits after decimal.
Yeah, but while calculating, will it use the 16-bit accuracy it had, like the large?
No, after decimal, you don't need 16-bit accuracy, in fact. 16-bit accuracy, what you need is the before decimal. Okay. Accuracy is not achieved by this. Accuracy is achieved by basically the whole thing. I mean, this whole thing. Okay.
Thank you.
Sorry, if we have to show in the output for larger numbers, as
yes.
like we have to show many decimal places after the decimal point.
Yeah.
So what do we have to do in that case?
Okay. Just show me. Tell me what number you want to represent. I'll show you. Suppose you want to calculate area of a circle.
Yes.
Okay. You want to calculate the area of a circle. You tell me the radius. Just tell me the radius so that we can do calculation. What is in your mind regarding the radius? You tell me the radius. Just a minute. ये क्या हो गया? Where is the? Yeah. Please tell me the radius.
So, whether it's a small radius or larger radius, actually,
tell me.
My question is not like that. I'm asking that if the precision point we have taken as a double, and the pi number is r is anything 0.5 centimeter or anything.
Yeah, that will be.
Yes,
that will be represented in floating point correctly.
Yes. So when the total area is already calculated and it will show as a area of the circle is something in our output. So we want to show the area of the circle to 10 decimal places after the decimal point.
Yes.
So how will we show in the output that we have to show 10 digits?
No,
it
you
will
cannot.
by default show 4.
Yes, you cannot see it on the monitor.
Yes.
Present day monitors you cannot see. You go inside, you can see in the I mean what is the contents of the location in a different manner, but not on the monitor. On the monitor, it will show only 4 places after decimal. That is sure. Although in within the memory, it will keep 52 bits for the Mantissa. 52 bits.
Okay.
That means it within the let me clear it. Suppose you are saying 1.79 into something. That means suppose something is 1.7932567843. This will be well represented inside the memory. It will be lying like this only. Okay. Suppose this is the number. This will be inside the memory, but on the monitor, please mind that only 4 digits will be visible to you. This is the thing.
Okay.
Yeah. Okay. It's like that only. Nobody can do anything for that. Monitors are meant to show only this because the memory of the monitor is limited. Memory of the computer is not limited, but memory of the monitor is limited.
Okay. Thank you.
Yeah. So we'll move further. So we were here. Just a minute. Let me come back to where we were. So what I was saying is that this number X was there. And okay. So your X was, if you remember it, it is given on the left also. In the workspace, you see 890.4764. Right? Suppose I write y equal to, let us say y equal to, and you want to convert it into 8-bit integer number. Okay, 8-bit integer number. So this is the way it is done. You have to write y equal to integer 8 x. So x will be converted into 8-bit integer. And let us see what it is. X was, you remember x was 890.4764. Okay. Now what is the answer when it is made an integer? This was a real number converted, and I have converted into integer. Now you must be wondering that when we convert a real number into integer, then only fraction part must have gone. It must have been clipped off. Rest is the integer. 890 is the integer. Isn't it? But the answer is 127. Why? Because you are asking it to convert into signed 8-bit. I did not write UINT, mind you. When I write UINT, then it is unsigned. So the limit of unsigned integer is from 0 to 255. I told you, I think. Okay, 0 to 255. That is the maximum positive number that can. When you write signed number, then it is minus 128 to plus 127. Rather, I'll say minus 127. Yeah, minus 128 to plus 127. That is for the signed integer numbers. So I wrote this when I wrote int 8 only. That means it is a signed number. It is being treated as a signed number. That means it could be negative also. Okay, MATLAB is thinking a negative number may also come. In that case, when it is a signed number being treated as signed number, the 8-bit integer values that are allowed by MATLAB or by computer, 8-bit means any 8-bit, not MATLAB, anywhere, it is minus 128 to plus 127. Because this number was greater than 127, this was 890. This was 890. So max, what it could do, it could not give answer as 890, chopping off the decimal digits. It chopped off the decimal digits, that is fine. But for the rest, that means the integer part of it, okay, that was 890. but 890 cannot be accommodated in 8 bits. Maximum number that can be accommodated in 8 bits for the signed numbers is 127. So it gave as Y value as 127. If you write, suppose, unsigned 8-bit, UINT. Now at this time, what I did, Y is being given value, unsigned integer conversion is being done for X. So when 890 point something gets converted into unsigned number, now the answer is 255. You saw the difference? Do you appreciate it? Get it? That these are the maximum number which is possible, positive maximum number, unsigned maximum number in 8 bits. So that's the reason. However, if you give unsigned integer 16, suppose I give 16, unsigned 16-bit, then your answer is 890, because 890 can be accommodated in 16-bit, no problem. So I think you can see. Now I'll give you an example of logical instruction, so that just instruction you will come to know. Then I'll tell you what is further that can be done with matrices. Suppose
I have a query.
Yes,
Shouldn't it give 65535 number? You are giving maximum number.
Not the maximum. You are converting the value of X. What is your X?
Okay. Okay.
You are not converting you are not asking it to give the maximum number. Okay, you are asking it to convert 890.4764 into integer.
Okay.
Pardon?
What is X here?
X was a variable which we defined. Just a minute. See, this was X.
Okay. Okay. Okay.
Okay.
Okay. Got it.
Right. So, okay. Now I'll give you an example of the logical instruction. Let us say I define a variable A, and I define it as equal to, now 40, I am using a logical instruction, greater than 50. You understand it now? What I'm saying is, there is a logical evaluation whether 40 is greater than 50, and whatever result comes out of 40 greater than 50, either it will be true or it will be false. That value will be assigned to A. This is logical instruction. Once again, I am asking computer to evaluate whether 40 is greater than 50. Either the answer will be 0 or 1. We are not bothered. Okay, well, that we'll see. But whatever answer comes, that will be assigned to the variable A. So variable A will be either 0 or 1, depending upon whether this condition is true or false. Now, in this case, 40 is not greater than 50. So that means this is false. Asking 40 greater than 50 or not, it will come out to be a false thing. So therefore, A will be assigned equal to 0, because false means 0 for MATLAB. So just see, I am executing this instruction. A has been assigned a value 0. If you do the reverse way, then that means reverse way means you ask 50 whether it is greater than 40 or not. Here I'll do 40, and then I am executing. Now A has got the value 1, because it is true. So 50 is greater than 40. Okay, so this is kind of logical step. Now the kind of character, suppose I write B equal to, all the characters are to be written within quote marks. So please mind. So Amod Kumar, suppose I write. They will start with quote mark, they will end up with quote mark. So that means what I'm doing, I am asking this is a string of characters. This is called a string of characters. It's not a single character, it's a string. And how many characters are there that we can count, of course. So this string of characters will be assigned to the variable B when I execute this. And just see, B has got a value, Amod Kumar. Okay. And on the left, you can see in the workspace also, you keep seeing that the variable which we are creating, that is coming up here. I think all these are A, value A, Hans, B, C, X, Y, all those which we created earlier, they are present in the workspace. And also, not only that, if you take this workspace bar horizontally, if you move, then you can see the values. What is the value of the variable? I mean, this is just for information's sake, nothing great in this. Value is available here also. There also it is showing what is the minimum value of this variable maximum. That it is useless. Anyway, so those character variable, I think you have seen. So variables I have shown you that they may be numerical variable, there may be logical variable, there may be character variable. At present, this is good enough. To higher type of things you can move later. Really, you will not understand structure and all at present. Okay. And if you want to clear the screen, then CLS will clear the. Oh, sorry. Clear will clear the this thing. CLC, sorry, whatever. CLC will clear the screen. Screen of means command window. Command window will be cleared. Whenever it gets filled, you give CLC. So it will be cleared. But variables are there in the workspace. Variables have not been cleared. Okay. Still the value of X is there, Y is there. You can do anything with the help of, so let us say I write Z equal to, let's say I write Z equal to X into Y. So those X and Y are there. So therefore X into Y, for into you have star here. Any high level language will have star for the multiplication, you know. So Z equal to X into Y, if you carry out this, so of course Z will be evaluated based on whatever was the value of X and whatever is the value of Y. So that you can see. Okay. So that means variables are there. And also, which variables are there in the workspace, which variables are there, you can ask it. You can ask MATLAB to give the names of those variables which are present. And the command for that is WHO. Who means you are asking MATLAB to list the variables. Now, let me execute who. What is the answer? Your variables are A, Hans, B, C, X, Y, Z. Are you getting me? Who. And also, if you give a command WHOS, that means whose, WHOS, then what it gives? It gives not only the variables which are present, but also their size. Now you will wonder, what do you mean by size? See, you have to understand that MATLAB takes any variable as a matrix. Okay. So all these variables which we created for MATLAB, they are matrices. And matrix have got certain number of rows and certain number of columns. So that their size is represented by row multiplied by column. Isn't it? So here, all these matrices, A, Ans, this is C, X, Y, Z, they are variables. They are one by one matrix. That means there is one row and one column in that matrix. Whereas you can see this B. B was Amod Kumar. Okay. Amod Kumar is not a single entity. It's a collection of characters. It's a row matrix of characters. It's a row matrix of characters. And when you say, let's say, let me show you. Just a minute. blank page. Let me show you. Just where it has gone. Yeah. Yeah. See. Just this has gone. Where this has gone. B equal to. We entered this Amod Kumar. Right? So B is a variable, which is a character variable because we entered this. So here, this is the string of characters. And how many characters are there? There are 1, 2, 3, 4. Blank is also a character. This is space. This is a character I told you. Okay. So this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 characters. So that means it is a matrix. Sort of, it is a matrix like this. It is a matrix like this for MATLAB, in which there are a total of 10 columns. Each character is a column, and there is only one row. One row. So there is one row. There are 10 columns. So it is a 1 by 10 matrix. So that is what is being indicated here. I'll show you. Just a minute. This B, you can look at this B. This is 1 by 10. Okay. So this is what it is. So at present, number of bytes it is occupying in the memory that you should not see. This is for the MATLAB that this particular variable is occupying 1 byte in the memory. 1 byte means 8 bits. ANS is occupying 8 bits. This is 20 bytes, sorry, 8 bytes. So that you should not see at present. But this you can see that what is the class of the variable. A was 40 greater than 50 or 50 greater than whatever it was, but it was a logical variable. So that is what it is showing, that it is a logical variable. ANS is a double type of numerical variable. This is a character type of variable. And these are all double precision real number type of variables. And Y and Z are unsigned integers 16-bit. I think, is there any doubt type of variable which you are not understanding? Tell me. I mean, the characteristics of each variable you can see with the help of this particular command, WHOS. Size, what is the type of variable, and if you are interested, how many bytes it is occupying, this particular variable is occupying in the memory of the computer. So this is the thing, right? So shall we proceed further? So let us go ahead. So okay. So for the this thing, variables, regarding the naming of variables, I want to tell you now. You can assign any name to a variable. You assigned A equal to something, nice. You want to assign A1 equal to something, no problem. Okay. You can assign any variable. That's not an issue. Okay. But that variable must start with an alphabet. That is the limitation. Later on, it can have numeral also in its name, but it should not start with a numeral. It should not start with a numeral. That is the limitation. So it should be an alphabet in the beginning. The first thing will be, or after that, it can be a numeral also. So only numerals and alphabets, they are allowed as the name of variables. First of all, this thing. Okay. Value can be anything. It may be a character type. It may be whatever. One thing. Second thing which I want to tell you is that certain names, certain variable names are reserved for MATLAB. Those are called keywords. Keywords. Those keywords you cannot take as the name of the variable. You cannot assign those keywords Okay. And what those keywords are, which are result? Those keywords are A and S. You have seen. You cannot use it as the variable name. Epsilon. I showed you it's a very small number. Epsilon is a very small number. It's a constant. Then I. This is reserved for the complex, this thing, part of the, this thing, complex number. Okay. Imaginary part of the complex number. Similarly, J is for the same purpose. Then what you cannot define is INF. INF. INF is reserved for infinity in the computer. For example, suppose you divide anything by 0. 5 divided by 0. So what is the answer? It is INF. So this INF, MATLAB has kept reserved for itself. You cannot use it. So I think this is clear. Then sometimes a thing will come not a number, NaN. So whenever the result of any numerical calculation is undefined, whenever the result of any expression is undefined, it will come automatically. Okay, we will show it later, but this is a number. This is something which you cannot use as variable name. Then I have already told you pi. These things you cannot use. Other than that, you can use anything. Okay. So this is what I wanted to tell you. Then what are the different operators which are allowed by MATLAB? That you know, probably many of them. First of all, unary plus. Unary plus. Unary plus means, suppose I want to write +5. That means that there is a single number and I want to tell that it is a positive number. So this is not wrong to write +5. You can write 5. That is good. But you can also write +5. So this is called unary plus. Okay. Then for negative numbers, you have to use unary minus. Unary minus. That means -10. मान लो. Suppose कर लो -10. So that is necessary, of course. Whenever there is a negative number and a single number, then it has to be preceded by a negative sign like this. Then there is a binary plus. Binary plus means addition operation. A plus B, 5 plus 10, whatever. Such type of things. Whenever this plus sign comes between two numbers or two variables or like that. No, it is plus. You know that. Then negative subtraction, that means subtraction. Binary minus means subtraction. B minus C, like that. No. So therefore, whenever you have to write and you have to assign, so D equal to B minus C, that is C will get subtracted from B, and whatever is the result, that will be assigned to D. So that is subtraction. So similarly here also, whatever, doesn't matter. Then multiplication. Okay, so that you know multiplication, B multiplied by F, for example, and you want to assign to P. Okay, do it like that. Then there is a division. Division means, let's say G equal to A upon B. Just like I did 5 by 0. So that was an operation of division. If you want to assign it to something, assign it. If you don't want to assign it, answer will be automatically A and S equal to something that you know. So division operation. Then raised to the power. Caret. This symbol is known as caret. This is on your screen, keyboard. Caret means, suppose 2 raised to power 3. So 2 raised to the power 3. Like suppose, for example, I'll show you here. 2 and this caret. Caret is above 6, no? This numeral digit 6 on the keyboard. So 2 raised to the power 3. So 2 raised to power 3 is 8. So therefore, answer is 8. So therefore, this caret. So raised to power. Again, let me insert a page. Okay. Then there is a sign like this. There is a symbol like this. This was division. This is division. Okay. And this is also division. That means you may call it left slash, you may call it right slash, like that you can do. So whenever you do right slash, this is, and if you are writing, let us say A like this, suppose you are writing. When you write A, this thing, that means this is A upon B. This is the mathematical operation which is done. When you write A and right slash B, that means computer will do B upon A. Okay, I'll show you. I will show you. Suppose 3 and this right slash is here, right slash is here, and 2. So it is not 3 divided by 2, rather it is 2 divided by 3. I think you can see. Okay. Whenever I do 3 divided by 2, then of course it will be 1.5. But whenever the direction of the slash changes, then this division is a reverse division. So this is the thing. Okay. Then what other things which are allowed with MATLAB? Let us say I write this way. This is a colon operation. I am telling you about colon operation. Colon means, like, suppose I write 1 colon 2 colon 10. I write this. What it means, I'll show you. Let's say array A equal to colon operation. I am showing you A 1 colon 2 colon 10. Let us say this. I execute this. When I execute this, just see what happened. That means the MATLAB generates a matrix, row matrix. It's a row matrix in which there is only one row. There are many columns. That is called a row matrix. Okay, or row array. You can call it row array. You can call it row matrix. Doesn't matter. Both are same things. So it generates a row array whose first element is 1, with which, I mean, you started your this thing variable 1. Then is to 2. Is to 2 means that the difference of the two numbers will be 2. That means it will be incremented by 2. The first number will be incremented by 2. So it has become 3. And that is the next thing. Similarly, again, next number is incremented by 2 and 5. This becomes 5. So similarly, 7. And 7 incremented by 2 is 9. So 9. Now, where will it stop? This last number is 10. So that means the value of A will go up to 10, basically. But now what happened is that after 9, the next number would have been 11, because the increment is 2, right? So 11 is more than 10. That it cannot assign. I mean, the maximum number is 10. More than 10 is not allowed by this command. That is what it says. So therefore, 11 was not printed. Only up to 9 it got printed, right? So therefore, your row array is 1, 3, 5, 7, 9. So first number is the initial number, second is the increment, and 10 is the maximum up to which it can go. Is there any doubt in this?
No, sir.
It's all right. So therefore, this is what colon does. Then another thing I'll show you. So now you understand that it is an array. I told you it is a row array. Now, if suppose this is the row array, which we write in mathematics like this, no? If you are a mathematics student, so that means suppose this is A, this was A. So I'll write this way. Matrices are generally written in square brackets, but that was in mathematics, not here. This was 3, sorry. 5, 7, 9. I think you understand. 1, 3, 5, 7, 9. So this is a row array. Row array or row matrix. Same thing. And this matrix is having 1 row and it is having 5 columns. So it is a 1 by 5 matrix for us. Here also you can see if you want to see the property of A. So you can see the property of A, WHOS. Just I'll show you. You can see it, property of A. It is a size 1 by 5. Can you see this? 1 by 5. And in the memory, it will occupy 40 bytes of memory. It's all the numbers are double precision numbers. Okay. So I think this is not a great issue, but it is a matrix having dimensions 1 by 5. Now, if I want to access an element of this matrix, I can do that. So therefore, suppose A, and then I write within parentheses. These are called parentheses. So let us say A3, for example, A3. Whenever I write A3, that means the third element of this matrix is being called. Okay. So as you execute this, the third element was 5. I will show you the matrix. 1, 3, 5, 7, 9. So the third element was 5. So whenever I write A3, third element will come. And you can do whatever you want to do it. You want to multiply this by A3, so you can. Okay, straight away you can. C equal to, let us say, what? C equal to X into, I can do that. X was a variable earlier defined. And now A3 I want to bring. So C is equal to X into A3. What it will do? It will multiply X with this element 5. So 890.4764 was X. A3 is 5. Both will get multiplied. Answer will be something. 4. See, I told you that large numbers, whenever numbers are large, then it will write it in floating point form. That means the answer is 4.4524 into 10 raised to the power 3. You can write this number as 4452.4. Okay. You can see if I copy this, and if I copy this in Word, suppose if I copy this in Word, this was the number. I'll magnify it. Okay. This was the number. It's 4.4524 into 10 raised to the power 3. So therefore, what I mean is this is equal to, if I take a different this thing, 4.4452.4. This is the same thing. This is the same thing. So it did not show this because MATLAB prefers to show the results in floating point form. That means the mantissa and exponent form. It's like that only. I mean, it gives output like this only. So I told you that any element of a matrix can be accessed like this. All the things can be, I mean, operations can be done with these numbers. Okay. So that's the thing. Okay. So parentheses, we were on parentheses. I wanted to show you the application of parentheses. So one of the applications is this, which you saw. Another application of parenthesis, suppose you want to divide 4 by, let us say 3 plus 9. So another thing you will have to do is this. See, I mean, I am dividing 4 by 3 plus 9. So because if you write 4 divided by 3 plus 9, simply, without parenthesis, so that will mean 4 by 3, and after 4 by 3, whatever is the result, that will get added to 9. This is what it is. According to mathematics, mathematics also gives a rule of hierarchy for carrying out different operations. And the hierarchy for division is more than the hierarchy of addition. So that means this particular expression, if you write, this will be evaluated as 4 by 3. That means 1.33 plus 9. So answer will be 10.33. I'll show you. First, okay. First, let me finish it. If you want to divide 4 by 3 plus 9, so I think you understand what I'm going to say. This means this. This means this, in fact. So that means it will be 4 by 12. Okay. So whatever it comes to 0.3 something, forget it. It will come something. So I'll show you that. Okay. So that you have to take care. 4 divided by 3 plus 9, and 3 plus 9 has been given in parentheses. So answer is 0.3333. But whereas if I evaluate the same expression without parentheses, just see 4 divided by 3 plus 9, what it comes to. 10 point this thing, which I told you, it will come like that only, 10.3333. So because it is like this only. Okay. So I think you understand this. So I'm in parentheses, so you understand very well. Not only here, parentheses go to make the things complete. Let me tell you, all the trigonometric operation or all the functions, they will use parentheses. Like suppose you want to find out cos pi, cos 180 degree. And you want to cos 180 degrees minus 1. Okay, right. Okay, it is minus 1. I don't remember. Cos 180 degree. So here you will write cos in, and here you write pi. Cos pi. So cos pi will come to be minus 1. So here also this pi has to be given in brackets. Okay. And in MATLAB, all the trigonometric functions, they will be, you have to give the angle in radians, not in degrees. So cos 180 degree will be something else, you know. Cos, suppose I write cos, then 180. So it will understand as if this 180 is in radians, no? So it will give something else that you can see probably. 180 radians is what? And you can evaluate cos here. So just mind that all the angles are to be mentioned in radians and not in degrees. Secondly, you have to use the parentheses to evaluate all the trigonometric quantities. Not only trigonometrics, many things. You have many functions. Suppose exponential of something, e raised to the power something. You have to evaluate e raised to the power. Let us say I have to do e raised to power 3. Suppose that means 2.71 raised to power 3. Sorry. Okay. So if there is a function, no, not e raised to power, because I think MATLAB doesn't understand e as such. It doesn't understand. Okay, we'll come to that. We'll come to functions. When we come to functions, I will let you know. Okay, just for the time being, let me introduce various operations. Just the operations. So therefore, you understand that this is this. Then next thing. Suppose you are writing a command, although this will be rare, but even then, suppose you are writing a command A equal to B plus C something, B plus C divided by, and let us say your command is not coming in one line. Are you getting me? Your expression is so long that it is not being accommodated in a single line on this command window. भाई इसकी limitation है. Everything has got a limitation. है ना? You can go up only up to the end of the line. After end of the line, how will you type? You cannot press enter, mind you, to write the next line of the command. Command is very long. You cannot enter in between. Because as soon as you enter, whatever you have written, that will be executed. Whole command will not be executed because you have not written the full command yet. Second line is there remaining. So in that case, what will you do? At the end of the command, you press 3 dots. Okay. So when you press 3 dots, then it will, I'll show you. This is in fact a vague thing which W raised to R4. Suppose this is the thing. Although it will not understand W because W is not there in its workspace, how it will understand it. B was there. No, B was also correct. Just a minute. A equal to, suppose X plus C divided by Y. Let me do this. Okay. These were the variables which are there in the workspace. So there is no problem. So X plus C by Y raised to the power 4, whatever it means. Doesn't matter what it means. Okay. And similarly, there are other things also. And your line has finished. Okay. Then I'm telling you that you print these 3 dots from your keyboard. You enter these 3 dots and then you press enter. Then you will come successfully to the next line. And you can write whatever you want to write. Z multiplied by, raised to the power, let's say 4 and whatever, plus, minus something like that. So this is what I wanted to tell you. Sometimes you may need it when your command is very long. Arithmetic expression is very long, which you are evaluating. Okay. Then, okay, this is fine. It did not understand what this was. Something it did not understand. Doesn't matter. At present, this is the thing. Okay. Other things, I think operations, they will become clear as they come. No problem. Right? So that's fine. Equal to stands for the assignment operation that you have seen many times. And other things I'll tell you. Okay. Then, regarding the operations which are connected with logical this thing, let me tell you about that. What all operations are allowed? See, just see, greater than operation is allowed. That means 40 greater than 50 as I did there. Whether it is true or false does not matter. Less than operation is allowed. Okay, this type of thing. Then greater than or equal to. This means greater than or equal to. And you understand what it means in mathematics. Whatever it means in mathematics, same thing in MATLAB. Okay. Then less than or equal to, that is allowed. Okay. In mathematics, we write this way. But here in MATLAB, of course, you cannot write. This symbol is not there. So less than or equal to will be written less than, and then after that equal to. So it means this. It means this. Then equal to. Whenever you want to write, let us say you want to verify whether 40 is equal to 50 or not. Doesn't matter. You don't see the answer. I'm just telling you the operations. We know that 40 is not equal to 50. But you want to verify whether variable A is equal to B or not. So how will you write this? You will write this like this. Okay. There are two equal to sign. And when there are two equal to sign, it no longer remain an assignment operation. It's no longer an arithmetic expression. Rather, it is a logical operation. Now, that means you are asking a question whether A is greater than, whether A is equal to B or not. So, for example, 40, whether 40 is equal to or not to 50. Whether 40 is equal to 50. You are asking it. And if you execute this, your answer is 0. Why 0? Because this is false. 40 is not equal to 50. So therefore, the answer is false. So I think you understand what I mean. So equal to means for testing equality. And then not equal to. Not equal to means this tilde sign and then equal to. This is called tilde. I don't know what you call it, but I've been calling it as tilde.
Yes, it's still there.
It's tilde only. So this thing is tilde equal to. That means it is not equal. Again, this is a question you are asking MATLAB, that whether it is not equal to. So whether the answer will be true or false. That means the answer will be either 0 or a 1. So these are the different relational operators. They call it relational operators, which are used to evaluate a logical expression. Which are used to evaluate a logical expression. Then further, let me move further. Then we have.
Yeah, sorry to disturb you, sir.
Yes.
With your permission, can we take a lunch break for 1 hour?
Now,
As per
shall we
schedule?
take it? Okay, we'll break it for lunch.
Yes, sir, as per schedule.
Or you tell me, please, sir.
Yeah, sir, we have to take 1 hour lunch break.
1 hour lunch. So okay, then we break for lunch.
Yeah.
After
Sir.
that, I'll
Thank you
continue.
so much.
I'll do the
Yes,
application
sir.
of this. All these.
1:30 p.m. We'll rejoin once again. If you have question, we will discuss in next section. So thank you, participants. We can end this session. Thank you, sir. Thank you so much for wonderful lecture.
Thank you,
all.
sir. Thank you. We'll meet after lunch.
Yes, sir.
Yes,
Thank you.
participants are requested to join 2 minutes before at 1:35, 1:30 p.m. so that we can resume our workshop.
Yeah. Thank you. Thank you, Rajat.
You can leave now. Thank you all.
Rajat, kindly stop recording.